Good afternoon everyone and welcome to today's webinar on the surface wear trailer. My name is Neela McCoy and I'll be your moderator today. So please feel free to contact me if you've got any webinar related inquiries, and my details are there on the screen. Today's webinar will run for approximately 45 minutes and there'll be 15 minutes for questions. We'll be recording the session today and I'll email you a copy along with the presentation at the end. Feel free to type any questions that you may have into the questions box, and if you experience any technical glitches, please just use the raise your hand function. Now, with any further delay, let's welcome our presenter today, Ulysses I from ARB Group. Ulysses, could you kindly tell us a little bit about yourself?
Good afternoon, everyone. So I've been working at ARB for about 8 years now, and most of that time I've spent in asset management. I find asset management is a really good area to work in because it really gives you, I suppose, a broad level of contact with different areas of road research. And each project I've done has been really interesting. And one of the more interesting ones I'm going to be talking about today, which is overseeing the latest work with the surface wear trailer. And so I'm going to begin talking today about a little bit about surface wear itself. So as people would know, if you're maintaining a road asset, one of the things you need to be watching out for is the rate of wear on the surface. If you're maintaining the road, you really need to have a good understanding of what sort of traffic and what sort of conditions are going to result in different levels of surface wear. This can also be an issue if you are concerned about access of certain vehicles. Obviously, larger and heavier vehicles are going to have more of an impact on the surface, and so if your area of responsibility is concerned with access within a road authority, you may be a bit hesitant to allow certain vehicles or certain class of vehicles to use a road if you're concerned about the impact that it's going to have on the surface. And so what that means is that we really need to have a really good understanding of what vehicles and what manoeuvres will impact on the surface and to what extent. And so currently, to try and achieve that, there are methods such as ESAs and others which can be used to get an indication of what the surface wear might be, but these are very much based on vertical loading only. They don't include any consideration of the horizontal loading that can occur. But it's been found that a lot of the failure that can occur in the surface is actually due to those horizontal forces rather than the vertical. So looking at surface wear, this is something which ARB has been involved with for many years, and over that time, of course, we've done many projects in this space, and over that time, through literature reviews and consultations with practitioners, there have been a number of, if you like, key things that have come out of that. One is that, of course, the surface failures often occur in those areas where those horizontal forces are precisely, if you like, the major impact that's incurred by the wheels of the vehicle. And so these happen in areas such as at intersections where there are turning manoeuvres happening, on climbing lanes, on steep descents as well, and areas where traffic is regularly starting and stopping. And it's even been found that these failures can actually occur with very few vehicles going through. Other findings have been, of course, over time there have been lots of experiments undertaken, both within the laboratory and also on the road itself. And an outcome of that testing has really been that if you really want to get a realistic and an accurate idea of what's actually going on, you really need to use a full-size rig which has a realistic tyre pavement interaction. And so that's really where the research is heading at this stage. And so all of this research has brought us to really what I regard as a key question or an aim, which is to understand the failure mechanisms that are particular to the pavement surfacing layer. So this is really just wanting to look at the pavement surface layer in isolation and say, with the damage that is incurred, how is it incurred and to what extent, and what are the vehicle factors or the vehicle variables that go into producing that. And so if we want to achieve this aim, to achieve this understanding, how do we actually do this? And ARB's answer to this is the surface wear trailer. which is a piece of equipment we've been developing over the past few years in our heavy vehicle group. And so basically what this trailer does is it replicates pavement surface forces by any single or dual tyre from any steer, drive or trailer wheel on any heavy vehicle combination undertaking any driving manoeuvre. Now that's a very long sentence with lots of words in it, but the key term in this is any, which you see appearing a number of times, because to take it more slowly, whatever section of road you want to investigate, you can take this trailer to that location and you can decide to test or simulate any vehicle undertaking any manoeuvre that you like, and you can target your simulation to any particular wheel on that vehicle, be it one of the drive wheels, be it one of the wheels on the trailer. So this piece of equipment is really able to simulate any vehicle doing anything, anywhere, basically. And so for that reason, it's something which is really, really useful in terms of investigating what's actually happening to the surface of the road when you have vehicles doing various manoeuvres. And you can see a shot of it here outside the Parliament House in Canberra, because we really regard this trailer as being something that's of national significance, if that's not talking about too much. But suffice to say, it's something that's really important and certainly very, very useful. And I'll be going over a little bit of the work that we've done so far and giving you a preview of the work we've got coming up to demonstrate that. And so I thought I would take you through some of the components of the trailer, because this is a really good way of getting an understanding of what the trailer actually does and how it does it. So this explanation is not going to be highly technical, so I don't think anyone's really in for that today. So this is going to be giving you a very broad overview of what's happening with the trailer in terms of what the parts do. And this is the first part you need to consider, because the trailer is really being built from the ground up. So this is the trailer axle group. Now normally the wheels on a trailer, of course, are just free running wheels. This is actually a repurposed drive wheels from a prime mover. And the reason why is because we wanted to actually take the drive. So these wheels, when they turn, they will rotate a drive shaft, which we will use later on. The main part of the trailer, the chest rig frame, was something which we had fabricated elsewhere and brought in. And we just see here just some photos of it just being assembled. So once those landing legs are put on, which you can see over there, basically the trailer, the form of it is of the housing of it is complete, and so then it comes to installing all of the components. Now, I mentioned the axle group providing the drive. The reason why we want to get that drive is because we want to run this test wheel, which you can see here, which sits in the center of the trailer. So this is the wheel, or wheel or wheels if you have a dual tire on there. This is what really is, if you like, the action point. This is the wheel that is used to simulate the interaction between the vehicle and on the road in terms of the one vehicle providing that providing that point of contact. And so what all these components do, the first one here is the transfer case. Now this provides, it's essentially a gearbox. It allows us to turn that drive shaft at a greater or a lesser rate than the road wheels are turning. The second component is this mid-train axle. Now this has within it transfers that drive to the next component, which is going to be the chain, which you see there in green. Then also this mid-train axle also has the brakes in it. And this allows us to brake that test wheel if we want to do that. The second is next to it is a chain, which just transfers that drive, as I said. And finally we have the test wheel mounting point, which we can mount a single tyre or a dual tyre. We can do a car wheel, or we can do a truck wheel. Most of the time of course, we're going to be doing the wheel of a heavy vehicle. So all those components together allow us to operate this test wheel, turning it at a faster or a slower pace, and also to do that dynamically, which I'll be talking a little bit more about later. Now this test wheel mounting point also has on this test rig. And so this is a dynamic test rig that allows us to basically apply the wheel to the pavement or to the road surface in whatever way that we need to do. And so it has you're seeing a lot of numbers here on the side, which I won't go through there. If you get the recording later on, you can look through those at your leisure. But basically, the key point here is that it's able to provide a variable load, and also it's able to maneuver that wheel, to turn it and also to tilt it to the side. What you can see here is that firstly it's able to do this, what we call a slip angle, where we're able to turn the wheel from one side or to the other. You would do this if you were simulating a trailer tire, because obviously when the wheel is turned, the motion of the SWT and the trailer is actually still in the forward direction, so the wheel is actually going to be dragged at an angle. That's what I mean by slip angle. And also we have camber angle, where we can actually tilt the wheel to one side or the other. As I mentioned before, we're able to provide a vertical load, and there are two mechanisms by which this can happen. On the leftmost picture here, you see a hydraulic ram. This allows us to provide a variable load where we can vary the amount of weight on the wheel over time. And secondly, we have these airbags, which provide a more static, if you like, load for the test wheel. And both of these are able to do that up to a load of about 7 tons. And you see just on the right there, they're just some of the air tanks that provide the pressure for both of those systems. And so after you have all those components, what that means basically is the test wheel is able to be applied to the pavement at whatever loading you like, and in whatever way, I'll say, that you like, depending on what maneuver you're trying to simulate. I'll be going through those in a bit more detail later on. These pictures you can see here, that's without the cover, of course, so you can see all the components inside. The test rig that I mentioned before is located right in the center, and the test wheel is there. Unfortunately, this is from the other side. With this side, you can see where the test wheel would be, but of course we raise it off the road, and we don't have the tire or the wheel, in fact, fitted when we're about to travel out and drive onto the road. So that's what it looks like.
Just looking at that picture, this is just some of the components that we have on the trailer. It looks like there's a bicycle wheel on it.
Yeah.
Is that something?
Yeah, that is basically there just to measure the distance that's being traversed. So when you're going over a test path, this is a wheel that basically just measures the distance that you're covering. Okay. That's one of many systems we have on the trailer that allows us to basically monitor what's going on.
Okay, fantastic. Thank you.
So what I'll do now is I'll just give you a brief overview of what happens when we actually go out to an area or to a site to undertake some testing. So here's a diagram of the trailer, which I spend a lot of time on. So hope it looks attractive. Basically, when we're undertaking testing, what we're doing is we have a section of road, and we have a test area that we've marked out. And so this will be an area that's representative of this road section, and also of other road sections that we want to get an understanding of. And so basically what happens is we drive the trailer along, it goes through the test area. You can see that the test wheel is in contact with the road, and we basically just drive through that area. Then when we reverse, you'll notice that we lift the test wheel up, and we go back, and then basically we just do it again. And then we'll do that a number of times, and then basically after we've done that a certain number of times, we'll start to see damage start to appear on the surface of the road. And so that's the basic, if you like, undertaking of using a trailer to basically, where the surface of the pavement involves is driving back and forth over the test area to basically accelerate the damage that would occur to the surfacing layer by the test wheel. And so the way that damage is, if you like, inflicted on the surface of the pavement depends on how you have configured your test wheel, what sort of test you're actually undertaking. And so what we see here is if you have the test wheel set up just to rotate at the same rate as the trailer wheels, basically what happens is it just rolls along the surface and nothing much happens. If you apply what we call overslip, where the test wheel is actually turning faster than the road wheels are turning, what happens is you start to impact the pavement, as you see along here. You start to wear the pavement, because what's actually happening is the wheel is actually pushing against the pavement. Now this would actually, or the road surface I should say, this will happen when you're accelerating, or if you're climbing up a hill, a steep slope. the wheel is going to be pushing against the road surface and wanting to turn faster than the free-running wheel would be turning. The opposite of that is underslip, which occurs when any of the wheels that have a brake on them are braking, so any of the wheels of a prime mover. So what's happening there is the wheel is trying to turn slower than the free-running wheel would be turning. And so once again, this will damage the surface. The other thing we can do is to have a slip angle. And as I mentioned before, this is where we turn the angle of the wheel, so the direction the wheel is facing is actually at some angle to the direction that's actually moving. So it's actually being dragged along the surface in the same direction as the vehicle while the wheel is turned in a different direction. And this simulates what happens to the wheels of a trailer when it's going around the corner. And obviously the tighter the turn, the smaller the radius of that turn, the greater the slip angle is going to be. So if you've ever seen an articulated vehicle undertaking a turn, you may notice that the trailer tires will actually get dragged sideways across the surface, and so that's what this simulates. And obviously I'll also mention the angle of the wheel is not only dependent on the ratio of the turn that the vehicle is making, it's also dependent on which wheel you're talking about, because obviously each of the wheels will have a different angle, they'll experience a different angle. And so we're able to simulate that. As I mentioned before, with the cycle wheel that you asked about, there are a number of sensors on the trailer which really allow us to have a really clear understanding of what's actually happening. So just some of them that I mentioned here, the tyre pressure, we can keep an eye on. We're able to monitor the surface temperature of the trailer, of the tyre, and we're also the slip angle and the slip ratio that we set the wheel to. We're able to monitor that and to make sure it remains constant during the test. And basically any other forces that are going on within the trailer, such as the vertical force, we're able to keep an eye on that to make sure it's not jumping around if we're trying to maintain a constant force through the test path. This piece of equipment you see here is something that works in conjunction with the trailer, because after you have inflicted damage on that surface, after you've worn the surface, you want to, of course, be able to measure actually how much you've done. And so this is a laser scanner that we use to scan the surface, and this will produce a three-dimensional scan of the surface. And so we do this before we've done any of the wearing. We do it afterwards, and of course we can also do it at points in between. So for example, it's quite common for us to do 5 passes with the trailer, then we'll scan the surface, do another 5, and then we'll scan it again. And this allows us to build up an understanding through those measurements of the actual wear that's been inflicted on the trailer. It's not unusual for, during the first few passes, for quite a few stones to be removed. The looser stones that are sticking up from the surface, and it kind of settles down for a while. But then as you keep going, then stones will start being removed. And of course, throughout there are texture changes. So what we're basically looking for when we're doing that, this scanning of the surface, is we're looking for 2 things. One, for stones being removed, and other for texture changes which occur when the stones are either moved around, either they're turned on the surface or sometimes they're just pushed further in. So that's basically how the trailer actually works.
Okay, great. Thanks so much for that. I do have one question that came in earlier, and that is, will the surface wear trailer simulate tri- or quad-axle vehicles?
It does. However, as you can see, because it's got that one test wheel on it, it basically only simulates at this stage the impact of one vehicle at a time. So if you want to, if your question is about the whole impact of the whole axle group, we really have to look at that wheel by wheel in order to build up that understanding.
Okay, great. Thank you. And just a reminder to everyone, to, if you have any questions, to please keep them coming through. Thank you.
All right, so what I'd like to do now is go on and talk a little bit about some of the previous testing that we've done. And so the first thing that we did was we wanted to be able to test out the trailer and, if you like, the experimental method in principle. So we did that by doing an acceleration point test. What that involved was basically placing the drive wheels of a prime mover at a point on a pavement and then having the front brakes on while we accelerated the vehicle. And so what that basically did was it made this, the drive wheel you can see there in the picture, basically turn on the spot and really impart some of those horizontal forces into this bit of pavement. So what you can see here, these are just some nails which are used to allow us to really line up the scans of the surface that we do. And so after we did this, you can see we had a photo before and a photo afterwards. And you can see clearly between these two photos that we have actually done something to the surface. And so with the laser scanner I mentioned before, of course we scanned the surface before and afterwards. And you can see here quite clearly that something has happened. And so by taking these two scans of the surface and minusing one from the other, we actually see down to a very fine resolution what the actual impact has been. So this allowed us to really test out this equipment in principle, and it proved that, okay, these two pieces of equipment we have, the trailer and this laser scanner, are actually able to work together to provide a measure of the impact on the pavement. So once we had that proof in principle, we took it out to a disused section of road. This now is just someone's glorified driveway leading down to a property. You can see on the end there. It was a bit of in-service road that was utilised for a normal traffic load, but now, of course, it's disused, just leading down to the property, as I mentioned. And so it was a great site for us to go out and test on. And so the testing that was undertaken here was to put the trailer through its paces. And so what that meant was that we basically did all the things you would have seen that the trailer was capable of. So we tested out the slip angle, the slip ratio, etc. on this road. And because this road was quite old, the surface had oxidised quite a lot. And so it was quite a strong surface, but we were still able to get a result. Just as an example of the kind of testing that's undertaken, one of the types of manoeuvres that we want to look at, of course, is when a heavy vehicle is undertaking a turn. And so what's being simulated here is just one of the wheels. This is the axle group from the trailer. You have to imagine there's a trailer with a prime mover in front of this, and this line is just the path that's been taken by this axle group. It's not the path of the prime mover. And so the trailer is being dragged through this turn, and we want to find out what's actually happening to this wheel here. And so as you can imagine, there's going to be a slip angle on this wheel. This is a GML loading, by the way, going through a 12.5 meter radius turn at a fairly low speed. What actually happens to that wheel when it goes through the turn, you can see here the three lines. The red is the slip angle that the wheel goes through. Obviously, when the trailer is being dragged in a straight line, there's no slip angle. Then as it goes through the turn, you can see here it goes up quite a lot, and at the midpoint of that turn is where you get the maximum of that slip angle. The blue is showing that the vertical force that's on the wheel, that will also peak at that midpoint, because as you can imagine, when the vehicle's going through the turn, the weight is thrown to that side, to the outer edge of the vehicle, and so the load will also, the vertical load will also be a peak at that midpoint of that turn. And so those two factors, the vertical load and the slip angle, combine together to produce the maximum of the green, which you see here, is actually the horizontal forces, which occur at that, are a maximum at that midpoint of that turn. So as you can see here, this is actually a very dynamic process where a lot of these values start out at a minimum and they increase up to a maximum and then they go down to a minimum again. And so if we wanted to, using this trailer, we can actually simulate that by using a hydraulic ram that you saw earlier, and also we can actually vary the slip angle as we go through, as we travel along a test path. So we're able to simulate that dynamically if you want to. But what's of greater interest is actually to just test the peak and that provides us with a constant horizontal force, which is the peak force at that turn you saw earlier. And so the reason why we do this is because in a normal turn, that peak force would actually be occurring at just one point on the pavement, a very small patch on the pavement. And so all that would tell you is only about that point on the pavement. Obviously, what we want to know is what is the result of applying that peak force over a test path. because this essentially gives us a number of samples and allows us to say something about this seal type, basically this seal type under these seal conditions before we came to do this testing. And so then if we have a number of, once we are able to say something where there's one site, if we have many sites of this type, and we do the testing on all of them, we're able to build up an understanding of how this surface performs when tested by or when it's subject to these types of manoeuvres. Because obviously the peak forces are when you're getting the majority of the damage. As I mentioned before, when we were doing those two scans with the laser scanner, this is what was done, where the grey scan was the original one and the blue scan was after 7 passes. So when we minus one from another, we're basically able to see the differences that have been incurred through those 7 passes with the material being removed. So as I mentioned before, it's quite common for large stones that are sticking up to be removed quite early, but then there are also texture changes, as you can see, with all this variation between the grey and the blue over here. And so that testing on that site was really, as I mentioned before, just to put the trailer through its paces and to make sure that it was able to do all the things it was designed to do. And that testing was successful from that point of view. So from this point, we then started our the testing of, I suppose, the actual the surface layer itself. Excuse me for a moment. So what we did next was we took it out to the ALF site, which is inside a shed. And what we're wanting to do is to look at the effect of testing. So what we had at the ALF site was a number of these pavement heaters, which are essentially just a number of bar radiator heaters inside an insulated A-frame. And so we put them across the a test track. You can see here a number of sites, which is A, B, C, and D. So over these we had each of the heaters, 3 heaters oriented like this, and we had 1 left for ambient. I should have pointed out the other one because D was actually ambient, and A was the hottest, B was next, and C was the coolest of the heated ones. And so what we were looking at with this testing was we really wanted to just look at what sort of temperature ranges are we looking at when, or what is the role of temperature basically in the susceptibility of the surface to damage. Unsurprisingly, the warmer it is, the more easily the surface is damaged. Excuse me. So what you can see here are some of the results that we had. Basically, each plot here is from a different of those test areas, going to A to D, with A, of course, being the hottest one. And so what was interesting about this was that on the very first pass, with the first time we did it, the surface was actually removed entirely. And that's what the exclamation point means. That's when the entire surface layer has been stripped away. And so you can see this happened at actually quite a low temperature, just above 45 degrees Celsius, which is actually not very hot. I should point out this surface at the ALF site was not it was perhaps not as strong as a surface you'd build for an actual road, but it was still laid in the same way. Sorry, excuse me. The difference between track 1 and track 2 was simply that we were basically running this experiment twice. And so if I just go back for a moment, you can see here that track 1, which you see here, is just to this side of the test plots, and track 2 was run through later, going along here. And so you can see that these are actually very, very close together. And so the interesting thing about these results is that despite these two being located so close together, the differences in the results is actually quite remarkable. So what this is showing that the surface in track 2 is actually a lot stronger than in track 1. And there was no obvious explanation as to why that would be so, because these were, as you saw, separated by about 20 or 30 centimetres. And so this shows that it's quite important to do your testing over a test path, because the results can be different over quite a short area. Next thing we did was we took the trailer out to a test site that's about 50 kilometres from Canberra, between the towns of, between Canberra and the town of Cooma. And the reason why we went to this site was because this is actually a binder test site where along this road, they have basically used different types of binder in the surfacing for about, each binder type accounts for about 300 metres, and they put these different binder types end to end. So they're all subject, of course, to the same environmental conditions and, of course, to the same traffic conditions because there are no major turnoffs along this length. And so what this means is that allows them to get an understanding of how the different binders perform. So there's a site like this near Canberra, and there's also one in Coopapedy. And so we took the trailer here to test on a number of sites. So these binders the surfaces were resealed with these different binder types about 4 or 5 years ago. And they've just been left there to see basically what will happen to the surface, how the different binders will perform. And so we took the trailer out to this site in order to test on a number of these surface types. And so the ones we ended up testing on were 3 types of polymer modified binder, S10E, S15E, and S20E. And we also tested on some S15RF, just some bitumen with crumb rubber added, and also on just some straight C170 bitumen as a control. And so we took the trailer out there to do that testing. You can see some rain clouds in the back there. On the very first day we got rained out, but on the subsequent days we were able to do that testing, and we were able to get some results out of that. Because it was getting towards the cooler months, this was in about May, so despite the sun you can see there in the background, you can also see some rain clouds, so it was quite overcast and it was quite cool, and there was wind blowing. So we took up these, which are some pavement heaters, which have in them just a bar heater and some insulated box essentially. Now, these worked very well at heating the pavement. They were able to heat it up to about 60 degrees. Unfortunately, because of the weather conditions, especially with that cold wind blowing, the surface also cooled down very quickly. So, but they made some difference to the temperature of the pavement at least. And so basically what we did was we set out a test site like this where we closed the lane. This builder string you can see here is a drive line that we tested on, and then basically we dragged along the road and we tested on, it was actually on this area here between the road patching. So of course we weren't interested in the areas that have been patched. We were looking at that original surfacing, and we did our testing just in there. The kind of results we were looking for, you can see here some things like, apart from stones being removed, some stones actually shifted, and we were able to see when they're moved, of course, because they exposed the binder. What you can see here is a number of loose stones on the surface. You can see them all over here, and these marks here are just the rubber off the tyre, off the test wheel. This was after we were doing the slip angle testing, where the tyre was being dragged through. And of course all these stones, apart from sweeping the surface clear, you can tell that all these have been ripped out from the surface because they've got little bits of bitumen on it, which you can see on some of the stones there. And so unfortunately the laser scanner on this occasion, it malfunctioned. We couldn't get it working. And so all that meant that our results on this occasion had to be based on counting of how many stones were removed by the number of passes and by the area as well. And so when we compared those results, what we saw, of course, as you'd expect, or as you'd hope, the straight bitumen, the C170, was the worst performer. And perhaps surprisingly, the binder with the crumb rubber added was actually the best performer. And the PMB binders were performing in between, but they performed a lot better than the straight bitumen, which is what you want to see. The general results here, these are really just a broad indication because of the nature of the work that we did. But basically it's showing you that by adding something to the bitumen, you are improving its performance, and that's what everybody wants to hear. But these are, as I said, just you can't take too much of these results at this occasion. At this stage, to really just provide a broad indication. So all that testing, that was really just the beginning of the testing we're doing, which is for the current project, which is an Australia's project to determine PBS infrastructure standards for first surface wear. I won't be explaining too much about that project today, but suffice to say that involves us undertaking a large amount of testing, which we've got coming up. We're currently planning where we're going to do that, and also exactly what surfaces we're going to test on. Basically, what we're going to be looking to do is taking the trailer to do testing on a particular seal type, whatever is the most widespread seal type within each jurisdiction, and we're looking for suitable sites being in-service roads where we're able to close a lane. It needs to be flat, unfortunately, so the trailer can go back and forth, and we're looking for sites where the surface is 2 to 3 years old. The reason for that is because we want to have sites where it's old enough for the surface to be bedded in by the traffic, but it's not so old that differences in environmental conditions and traffic wear are going to make a huge difference. So after 2 or 3 years, that's probably really the time where the roads, despite their different traffic levels and different environmental conditions, will probably all be, more or less similar, barring, of course, any extreme traffic or weather. In the future, of course, we're going to be looking at tyre performance. You can see here there's the test tyre, which has a bit of rubber hanging off it. Obviously, when we're wearing the road surface, we also wear the tyre as well. And we've already been contacted by a couple of tyre manufacturers who would like us to go and do some testing. And so that's something we'll be looking for in the future. And of course, we're also going to be looking at doing more testing of binder performance. So after the conclusion of this Austroads project, this trailer will be available to go and basically test out the performance of different binders by seeing how they hold up to different manoeuvres being undertaken by different vehicles at different locations. And so it allows you to test both the binder and also the design of your seal for a particular application. So that's basically an overview of the testing we're doing currently and what we've got planned for the future. And I'll mention again that we are currently doing that, organising that testing that we want to do, where we want to take this trailer preferably to as many jurisdictions as we can, both state and local, in order to be able to build up a really good understanding, or start to build up a really good understanding of how basically different binders perform under different impacts from trailers, or from heavy vehicles, I should say, by using this trailer. So if anybody out there would like to help us find sites, that would certainly be appreciated, and you can see my contact details there. So I hope that was interesting and has given you an insight into what the SWT is and what it can do.
Great, thank you very much for that. I do have one more question that's come in from Andrew, and that question is, can it simulate a steering wheel, for example, dynamic change in steer angle?
Yeah, it certainly can, because like I said, we're able to control the load on the wheel and also what angle it's at. And there's no reason why we couldn't, if you wanted to turn the trailer itself, to do a curved test path if you wanted to do that. And like I said, we can control the angle of the wheel dynamically, so really we are able to simulate any wheel, including a wheel on a steer axle.
Okay, great. Fantastic. I just want to thank everyone for joining us today. If you've got any further questions, don't hesitate to contact Ulysses. And also, just at the end of the presentation, a survey will launch, so if you could kindly give us any feedback. And we hope that you'll all join us again for future webinars. Thanks very much.